Morning, everyone. Welcome to the OneClass channel. I hope you're all having a good morning. Today I'm going to help you through some algebra problems, high school level to college level. My name is Marlyn. I'm an undergraduate student at the University of Waterloo. I'm studying chemical physics with a minor in math. And yeah, that's all there is about me. Be sure to check out the links in the description if you're in need of any extra help. Okay, let's get started. So for our first question, we're going to want to expand a plus b cubed. So, to the power of 3, sorry. This can be written out as a plus b squared multiplied by a plus b, because we just add the powers. And when we want to expand a plus b squared, we're going to use FOIL, which is just a quick way of remembering how to multiply out these brackets. And so what you do is you take the first part, a, multiply it by the entirety of the second bracket, a plus b, plus the second part, b, a plus b. And with FOIL, that would be written as, and so you do a by a plus a by b, so this part, plus b by a plus b by b, the second part. And that should give us a squared plus ab plus ab plus b squared, which is a squared plus 2ab plus b squared. And now we are going to want to multiply this by a plus b. And similarly, we'd use FOIL, and because this one only has 2 terms, it's what I'm going to use as my outside. And so if you want to rewrite this and apply FOIL, then we do a times a squared plus a by 2ab plus a by b squared plus b by a squared plus b by 2ab plus b by b squared. And so when we write that out, a by a squared is a cubed plus a by 2ab, 2a squared b, plus a by b squared, ab squared, plus plus b by a squared, so ba squared, plus b by 2ab, so 2ab squared, plus b by b squared. And that is b raised to the power of 3. And when we simplify this, we see this term can be added to a squared b, this one, and ab squared can be added to this one. So we're going to get a to the power of 3 plus 3a squared b plus 3ab squared plus b raised to the power of 3. And this should be our final answer. And it matches the solution here. Okay, for our next problem, we're going to be making use of the quadratic formula. and we're going to use it to solve 2x squared minus 8x is equal to -7. And if you want that in quadratic form, to use a quadratic formula, we're just going to bring this 7 right over. And it can become 2x squared minus 8x plus 7 is equal to 0. And we know that for ax squared plus bx plus c is equal to 0, the quadratic formula looks like this. So negative b plus or minus root of b squared minus 4ac over 2a. So now let's just plug in our actual value. So we know that b is -8, so negative of -8 is +8 plus or minus the root of b squared. So that's going to be 64 minus 4 into 7 by 2. I'm just going to square root all of that over 2 by 2. So that would be 8 plus or minus the root of 8 over 4. Now let's rewrite this. We know that 8 is equal to 4 by 2 over 4, and that's 8 plus or minus 2 over 4. And so finally, this would give us a final answer of x1, which would be just one moment. And 8 over 4 is 2 plus and then 2 over 4 is 1 over 2, so we're just going to have root 2 over 2, and x2 would be 2 minus root 2 over 2. Okay, perfect. And so there's a slight mistake in this one because of the 2a, and we know that a here is 2 and not 1. Okay, on to our next one. Okay, so we want to write this equation in vertex form, and vertex form just means we want to write y is equal to 6x squared plus 12x minus 10 in the form of y is equal to a x minus h squared plus k. And so here we can clearly see that a is going to be equal to 6 because it is common in the first two. So 6, let's see what it's going to be. I'm sorry, 6x, which is, nope, let's leave the 6 in so we can get the squared term. So let's just leave it as x squared plus 2x minus 10. And so now we want to find what the quadratic we can find with the first term of x squared, second term of 2x. So we need to find what c is going to be. And we know that when we have x plus a squared, we get x squared plus 2ax plus a squared. And in this case, 2a is equal to 2, which means a is equal to 1. So for our, in the brackets, we're going to have 6x plus 1 squared. But with this x plus 1, it's going to have this additional term. So what we're writing here is technically x squared plus 2x plus 1. But we didn't want to show that one, and we're going to have to take it off. So let's subtract 6, because we multiplied it by 6 here, and then minus 10. And let's just clean that up. Minus 16. So here we clearly have a term of h is equal to minus 1 and k is equal to minus 16. And we should see our vertex at hk, which means our vertex should be at -1, -60. Okay, so for this question, there are actually two ways to do it. The longer method is listed, and you can go check it out in the answer. It is correct. I'm just going to teach you the easier way to do it. And we're going to use substitution. So let's just write it out. X minus 3 squared plus 2x minus 3 minus 8 is equal to 0. And you can make a substitution here to make it a quadratic. And so if we set u as equal to x minus 3, then it becomes u squared plus 2u minus 8 is equal to 0. And in order to find what terms would give us this, we know that, to find the zeros, we know that it should be u squared plus 2au. Actually, let's not solve it that way. So we're going to use product sum, and it just states that the product should be AC, the sum should be B. So AC would be 1 times -8, and that's -8. Sum should be 2. And what numbers could give us that? It would be 4 and -2, because when we add them, we get 2, and when we multiply them, we get -8, which means that our zeros are u plus 4 and u minus 2 is equal to 0, which means u is equal to -4 and u is equal to 2 for this equation to be true. And now let's just back substitute in x minus 3 is equal to -4 and x minus 3 is equal to 2. When we bring the 3's over, we get x1 at -4 plus 3, so that's going to be -1, and x2 at 2 plus 3, which is going to be 5. Okay, so we want to find the equivalent logarithmic or exponential form of the equation. So let's just create a nice little table. Logarithmic form, exponential. So to relate logarithmic and exponential form, we know log A B equals C is the same thing as taking this A over here as the base and writing it as AC equals B. So for the example of log 8 equals 1, we take this 8 to be the base and it would become 8 to the power of 1 is equal to 8. For our next one, we're just going to repeat that. Take the 8 right on over. It becomes 8 squared is equal to 64, which is true. You should get genuinely true statements. Otherwise, something is wrong with how you're doing it. Okay, so now we want to do the opposite. And so we know when we have AC equals B, it can be written in logarithmic form as this. And so if we have C is 2 over 3, A is 8, and B is equal to 4, it becomes log 8 of, sorry, just one moment. Four equals 2 over 3. So if you just brought the 8 over, you'd reverse what we just did. And so let's write that first. And repeat that similarly for the next one. And it becomes log 8 512 is equal to 3. So 8 to the power of 3 is equal to 512. And then lastly, no, we have two more. Now we're going again in the reverse direction, and we know that we just bring the 8 right on over. So log 8 1 over 8 is equal to negative 1. 8 to the power of negative 1 is equal to 1 over 8. And for our last one, which is reversing that, we have log to the base of 8 1 over 64 is equal to negative 2. So the reverse, in order to get it back into this form, 8 negative 2 is equal to 1 over 64. And we're done. Okay. So for our next question, we want to know what substitution we could use to rewrite this as a quadratic equation. So we know that quadratic equations are in the form a, let's use a variable other than x to avoid confusion. So au squared plus bu plus c is equal to 0, okay? And so in our scenario, we of course know the coefficients already. So a is equal to 4, b is equal to negative 21, and c is equal to 20. And now we want to find what substitution we can make to make x to the power of 4 equal to u squared. And we could easily write that as x squared, we take the square root of both of these, is equal to u. And so we would get 4 u squared, which is x to the power of 4, minus 21u, that's x squared, plus 20 is equal to 0, and it's in quadratic form with the power of 2, power of 1, power of 0. So this is our final answer. You can use any variable, whether that's u, y, you can use x again, but that would be very confusing. It's completely up to you. Okay, we want to factor this equation here. So 2x squared minus 3x minus 2. And in order to do that, we're going to have to split this term, which is usually what you have to do if you have a non-1 coefficient in front of the x squared. And so let's rewrite that as plus x minus 4x minus 2. And here we can clearly see a pattern of, we can get the same thing in the brackets if we take out x here, and it becomes 2x plus 1. And similarly, we take out minus 2 here, and it becomes 2x plus 1. And that's why we had to split this, in order to make that clear. And this is just FOIL, so it becomes x minus 2 by 2x plus 1. And that's evident because plus 1 times negative 2 is negative 2, which is our last coefficient here. Okay, for our next question, we will be completing the square. Okay, so we have x squared minus 8x is equal to 9. And we want to write this side in quadratic form and take away whatever coefficient is here as the c in order to make it translate to x squared minus 8x. And so we know that if we have x plus a squared, we will get x squared plus 2ax plus a squared. So 2ax is equal to negative 8x. Let's just cancel out the 8's. And so 2a is equal to negative 8, which makes a is equal to negative 4. So in that case, what the final number would be a squared, which would be 16. So we would get x plus a, sorry, x minus 4 squared, and that would be x squared minus 8x plus 16. And so if we want to write this side of the equation as x minus 4 squared, we're going to have to subtract 16 from both sides, and so that would mean subtracting 16 from here. And so that becomes x minus 4 squared minus 16 equals 9. And so we just take over the 16. And so if we square root both sides, is equal to plus or minus 5, because you can get the positive of the negative square root. And so x1 is equal to, let's take positive 5 plus 4 when we bring over the 4, and that becomes 9. x2, we take the negative, so negative 5, and we add that 4, and it becomes negative 1. And these are the solutions to this equation. So, when I gave the example of the quadratic formula, we learned that x is equal to negative b plus or minus b squared minus 4ac over 2a. This term here this one is what we call the discriminant. And so depending on its value, x could be different things. And so d is equal to the root of b squared minus 4ac. Okay, so let's think of the different scenarios that we could have. So if d is equal to 0, that means that this plus or minus is no longer relevant because we'd only have one solution, and that would be negative b over 2a. So we know if d is equal to 0, we get one real solution. If d is greater than 0, sorry, and we've seen this when we had the square root of 8. That means that this plus or minus is relevant, and you will get two real solutions because you'll be adding and subtracting a real number. And so when d is greater than 0, we have two real solutions. Now let's check what happens. Sorry. The discriminant is only what is inside of the terms. That is what we're discussing here. Okay, so now let's check when d is less than 0. So b squared minus 4ac is less than 0. That means that we're taking the square root of a negative, and that would give us complex numbers. And so you would get a real number plus or minus a complex number. And so that would mean that we would get, for d is less than 0, two complex valued solutions. Okay, so we are told in this problem that the quadratic equation has exactly one real number solution. And so for one real solution, that means d is greater than 0 in order for you to get that one solution. Okay, on to our next question. So if f of x is equal to 3 minus 1 over 2x. We want to find f of x plus 1. So what is usually in this bracket is just what we're putting in the place of x. And so in the scenario of f of x, we put x in the place of x. So if we had, for example, f of u, we just do 3 minus 1 over 2 and replace x with u. Which means that in the scenario of x plus 1, we're just replacing x with x plus 1. So it becomes 3 minus 1 over 2 by x plus 1. And when we expand that out, that becomes 3 minus 1 over 2x minus 1 over 2. And 3 minus 1 over 2 is the same thing as 6 over 2 minus 1 over 2, which is 5 over 2, 2.5. So it becomes 5 over 2 minus 1 over 2x, and we can simplify that to 1 over 2 multiplied by 5 minus x. And that's our final answer. Okay, and so now we want to factor x squared minus 9. And so we're going to use difference of squares, and that states that a squared minus b squared is a plus b multiplied by a minus b, and when you actually do the FOIL, you would get a squared minus ab plus ab plus b squared. So it's obviously correct. And so now we just want to write this as a square term, and it is x squared minus 3 squared. And so when we write that out, it becomes x plus 3 because our b is now 3, and x minus 3. And that is the factored form. Okay, so we want to simplify 2 minus 2i all raised to the power of 2 in our next one. Don't let the I confuse you if you haven't seen that before. It just stands for the square root of 1. So let's just write that down. And this is just the basis of complex numbers. And so let's expand it and just treat I as a normal variable. And so 2 minus 2i squared is equal to and if we just use FOIL but the long way, just so you can see everything, we get 4 minus 4i minus another 4i plus, let's just leave this 2i squared as it is. So that becomes 4 minus 8i plus 4i squared. And so if I is equal to negative 1, then I squared is equal to, square root of negative 1, I squared is equal to negative 1. And so when we put that in, 4 minus 8i plus 4 into negative 1, and these two cancel, and so our final answer is just 8i, so negative 8i. So negative 8 multiplied by the square root of negative 1. Okay, so we want to expand this expression using the law of logarithms, and we need to know what that is before we can do that. And that simply just states that log a can be any number, so in this case it's 3. M by n, if m and n are numbers, is equal to log am plus log an, but this is only in the scenario that both of them have the same base if you're going in the other direction of the equation. And so if we have log 3 to xy, that can be written out as log 3 2x plus log 3y, and this can be separated further because this is also multiplication. And so we get log 3 2 plus log 3x plus log 3y. And that's just how you expand it. Okay, for our next question, we want to solve this equation for L, and that just means isolate for L. So we want to have L on one side of the equal sign and everything else on the other side. So we can start doing that by subtracting negative 2w from both sides. And then simply dividing out the 2. So we get L is equal to P over 2 minus W once you simplify this. And that's our final answer. Okay, so now we want to factor completely x cubed plus 64. And so for this, we're going to use the addition of cubes, and that just states that a cubed plus b cubed is equal to a plus b into a squared minus ab plus b squared. Usually if it's plus, you're going to see the same sign here, the opposite sign here. This will always be a plus. And so if it's a cubed minus b cubed, you get a minus b, a squared plus ab plus b squared. And so now we just need to write this in cube form. And to the power of 3. So the cube root of 64 is going to be 4. Yep. And so x cubed plus 4 cubed. So x is a and b is 4. So let's just write that out. Plus 16. And that's it. And this is our final question. So you want to find an expression equivalent to 4 plus 6i squared, and we can do that by expanding it out. So 4 plus 6i squared is 4 plus 6i multiplied by 4 plus 6i. And so we could use FOIL. So 16 plus 24i plus another 24i 6 plus 6i squared. So 16 plus 48i plus 36i squared. And recall I is equal to square root -1. So I squared is equal to -1. And let's just put that in. 16 plus 48i minus 36. And that just becomes 48i minus 20. And that's our final answer. Okay. And so that's all for today. Thank you for listening. If you need any extra help or want to check out some extra problems, we do have them on the website, and you can check out the links in the description.